Okay, finishing our lesson on slant asymptotes and graphing of the rational functions. Okay, we actually did go over this part last time. By the way, this is the first problem. I kind of had to redo it. Something happened with the other one. There's the first problem. That's what it should look like. The second example, now it says let's graph rational functions with a slant asymptote, because this time we will have one. In order to have a slant asymptote, the function cannot have a horizontal asymptote, meaning the degree of the numerator is greater than the degree of the denominator. So we'll put greater than the degree of the denominator, and we're going to add by 1. The numerator's degree must be 1 more than the denominator. If it's 2 more, you won't have a slant asymptote. So this means it has to be top heavy, and again, it has to be top heavy by 1. So as you can see in our example here, we have x squared on the top and we have x on the bottom. Therefore, the degree of the numerator is exactly 1 higher than the degree of the denominator. Okay, we're going to still find all the other stuff that we've been finding. So the first two things that we find before we do any kind of manipulations or factoring or anything else like that is always going to be the horizontal asymptote, if there is one, and the y-intercept. So in this case, again, the top is heavy. So there is no horizontal asymptote because this numerator is going to grow faster than the denominator. Therefore, the fraction is going to keep getting bigger and bigger, and we won't approach any specific value. So when we put horizontal asymptote, there aren't any. It's none. The y-intercept, again, one of the easier things to do, y-intercept is going to be what you get when you plug in, this is not writing where I'm writing it. That's better. The y-intercept is when you get what you get when you plug in 0 for all the x's. Well, if I plug 0 into the top, I get 0 minus 0. If I plug 0 into the bottom, I get 1. So I end up with 0 over 1, which is still 0. So my y-intercept is, excuse me, 0, 0. Which means, of course, you will also have an x-intercept at the origin because you have 0 in the x spot as well. Okay, so now let's go ahead and we'll go ahead and find, by factoring, we'll factor out an x on top, leaving an x minus 1, and then we've got an x plus 1 on the bottom. We'll go ahead and find our vertical asymptotes and holes if we have any. Nothing cancels out here. I've got an x minus 1 and an x plus 1 on the bottom, so those aren't going to cancel out. The x does not cancel anything out because it's not being multiplied by anything on the bottom. So we don't have any holes. And the vertical asymptote is what makes the denominator 0 as long as it also doesn't make the numerator 0. So in other words, once we've simplified it, what makes the denominator 0? This is already as factored and simplified as we can get it. So what I would place in the denominator would be negative 1. So the vertical asymptote is the equation x equals negative 1. It is the vertical line. Now we have to look for the slant. Now we have some work to do. And this goes back to that long division, which we didn't really get to cover a lot of, but this is what we have to do. So we have to long divide this fraction up here. So x plus 1 goes on the outside of our division symbol. Then our division symbol is going to be x squared minus x. I'm going to put a plus 0 here as a placeholder for the constant. You should have a placeholder for every single term. I don't know that we'll come across one, but if you didn't have a term in between your x squared and a constant, you'd have to add the x term in there, but it would have to be 0x to make sure it's a placeholder. Again, I don't think that we're going to come across that. Okay, again, ask yourself, what do you multiply by x to get x squared? That's what we're trying to ask ourselves. Well, I would have to multiply x times x to get x squared. So when I multiply them, I'll put the x up here. Then I will distribute the x to the x plus 1, which is going to be x squared, x times 1, so that's x times x, and then x times 1 is going to be plus x. put a bar, and we subtract. X squared minus x squared goes away. We needed that to happen. Now the important thing is here to keep track of your signs. Now I've got negative x from there minus x from there, which is really going to give me negative 2x. And then we bring down the 0. And then we repeat the process. Ask ourselves, what do we multiply x by to get negative 2x? Well, of course, that would be negative 2. So I'm going to multiply by negative 2. Negative 2 excuse me, times x is negative 2x. Negative 2 times 1 is negative 2. And really, this part doesn't even matter. Whatever we get here for a remainder isn't going to matter. The biggest thing is you have to make sure that first term goes away. And negative 2x minus a negative 2x, of course, is 0. Technically, your remainder here would be 0 minus minus 2, which is plus 2. So you would have a remainder of 2. But the remainder does not matter for the horizontal asymptote. I'm sorry, the slant asymptote. So your slant asymptote is the equation y equals x minus 2. It is that line. That's the line we're talking about. That's the slant asymptote. All right, the only other things we have to figure out now are the x-intercept in the domain. So we'll do our x-intercept. X-intercept is what do I plug into x's on the top in the simplified version to make it 0. I have 2 of them. From this one right here, obviously I would plug in 1. But don't forget, I do have an x out here. What would you plug into x up there to make it 0? Well, it's just 0. So I actually have 2 x-intercepts in this case. So my first x-intercept is when y is 0. I'm sorry, yeah, when x is 0. Well, we already knew that one. That was the same as the y-intercept. But I have another one, which is when x is 1. So it's 1, 0. So I've actually got 2 x-intercepts in this case. And then the domain. So our domain is going to be eliminating anything that makes the denominator 0, which was x equals negative 1. So we're going to go from negative infinity to negative 1. And then from negative 1 to infinity. That's the domain of this function. All right, now we have everything we need to do to graph it. So let's go ahead and graph the asymptotes first. The vertical asymptote is x equals negative 1. That's right here. There aren't any horizontals because we have a slant. So our slant asymptote, y equals x minus 2. Well, remember that this right here is in y equals mx plus b form, where b is negative 2. That's your y-intercept. So we're going to go down to negative 2 on the y-axis, put a dot there. And then y equals x minus 2, the slope of that, because the slope comes right before the x, is 1. So the slope is up 1 over 1, or up 1, right 1, excuse me. So there's up 1, right 1, up 1, right 1. So I can put a dot there. I could put a dot there. I could put a dot there. I'm going to follow that pattern right there. And again, I'm going to dash these. This is my slant asymptote. So now when we go to graph our function, it's going to actually follow that flow when you graph it. And you'll see what I mean in a second here. All right, so let's plot our points. We know we have an x and a y-intercept at the origin, 0, 0. And I have another x-intercept at 1, 0, which is right next to it practically, right there. All right. So if you take a look at this, again, you have to think of this in terms of how the flow of this is going to go. If I start at the origin point and I go to the left towards my vertical asymptote, the function only has 2 choices. It can either go up to infinity or down to negative infinity. And in this case, because of the flow of the asymptotes, we know this one's going to go this way. And then as you go to the right from there, now it's going to dip below because it's got to go through both of these x-intercepts. It's going to dip below here, and then come back up through here, and then it's going to go up along the slant asymptote. So that's what your graph is going to look like in that section. I can't have anything in this lower right section because that would make this not a function. It would fail the vertical line test. So as I go to the left, I can pick a test point if I would like to and see if that works, or just figure out what the value of the function is going to be. If I were to plug in something to the left of my vertical asymptote, which is at -1, I'll plug in -2 into my original function. If I plug -2 in, so f of -2 is going to be, what's that, -2 squared minus -2, be very careful on that, over -2 plus 1. So -2 squared is 4, minus -2 becomes plus 2, and then -2 plus 1 in the denominator is -1. So what I get is 6 over -1, which is -6. So if I go to -2, I go down 1, 2, 3, 4, 5, 6 right here. So that tells me another point, which means that my graph now has to exist in that little kind of triangular area in the bottom. And we're just going to do a basic sketch. I don't know. Oops, that was horrible. I don't know exactly what this thing's going to look like, but it'll look something like this. I kind of missed my dot, so we make the dot bigger. There we go. And that's the general idea of that sketch. All right, so let's try a couple of more. We'll move a little bit quicker through these next three. Oh, actually, no, we're going to move a little bit quicker through this next one, and then the last ones are for you guys to try. All right, so the next one, x squared plus x minus 6 all over x plus 1. It will have a slant asymptote because the power of the numerator is exactly 1 higher than the denominator. So again, let's go through our process. We're going to find the horizontal asymptote first. And again, because the power of the numerator is greater, there aren't any. We're going to find the y-intercept. I keep doing that. For some reason, I keep trying to do a y-intercept. I keep putting the dot over the dash. All right, so the y-intercept is what I get when I plug x's in for, zeros in for all my x's, which is just going to leave you with -6 over +1, which is -6. So 0. -6 is my y-intercept. Okay, let's go ahead and factor this. If it factors, it looks like it does. So that's going to be x plus 3, x minus 2 over x plus 1. All right, so my, excuse me again, my wholes, I have nothing that's going to cancel out, so I don't have any. My vertical asymptote is what makes the denominator 0 once I've canceled my wholes out, if there were any, which is going to be x equals -1. It is a vertical line, so it's the equation of a line. Now again, I know I'm going to have a slant because the power of the numerator was exactly 1 greater, so we got to do our long division. All right, so x plus 1 goes on the outside. On the inside, we put x squared plus x minus 6. And again, ask yourself, what do you multiply by that first term on the outside, which is x, to get the first term on the inside, which is x squared? And of course, again, that would be x. Put it over top of your x term. So x times x is x squared. X times 1 is x. This is interesting. If I subtract these two, I get x squared minus x squared, which is 0. That has to happen. And then I get x minus x, which is also 0. Okay. So I'm going to bring down -6. Now I wrote 0 minus 6. That's really kind of an inaccurate way to write it. So let's write it the correct way. I need to still have that placeholder for the x's. So I'm going to call it 0x. It's still 0, but at least I know that there's an x term there. And it also helps to visually see, what do I multiply times x out here to get 0x? Of course, the answer to that is 0. So I'm going to put plus 0. We really don't need that in the end, but you'll see what happens in a second here. So that's 0x, and then plus or minus 0, doesn't matter. If you subtract these two things, you're going to get -6 for a remainder. The remainder doesn't really matter. So my slant asymptote is just the equation y equals x plus 0 technically, but the 0 is really only there to let you know that the y-intercept is 0. Of the slant asymptote, not of the graph, of the slant asymptote. I want to make sure you guys understand that. All right, and then we have, let's see, what's left that we have to do. We have to do the X-intercept, which is going to be what we get when we try to make the numerator 0. We have two of them now. We're going to have x equals -3 and +2 from the numerators. So we're going to have x equals -3, 0, and +2, 0. And then the last thing is the domain, which is eliminating what makes the denominator 0, which is x equals -1. So we'll go from -infinity to -1, and then from -1 to infinity. All right, let's graph everything. We have our horizontal asymptote, none. We have our vertical asymptote at x equals -1, which is right here. We have our slant asymptote, y equals x. Hopefully most of you know it's just that 45-degree line that goes right through the origin. But remember that your y-intercept of that line would be here. The slope is 1, so again you could put dots like that if you need to, and then just kind of get yourself the general idea. Again, this is a sketch. It does not have to be perfect. So it looks very similar to the last one we did. The difference is we've got different y-intercepts here. So let's see what we got going on for the x-intercepts and y-intercepts. Y-intercept is at 0, -6. 0, let's see, 1, 2, 3, 4, 5, 6 down is right here. There's the y-intercept. X-intercepts at -3, 0. -3 is 1, 2, 3 is right here. And another x-intercept is at 2, 0, which is right here. So on the right side, you can kind of see how that one's going to work. If it follows the pattern of the asymptotes, it certainly looks like it's going to do something like this. And then on the left side, because I do have that other x-intercept, I can actually follow the flow of this one now to know that as I go towards the vertical asymptote, as I head towards that one, it's going to have to go up. And then if I follow the flow of this one, it's going to have to ride that slant asymptote like that. So it should look something like that. And you can of course plug this into your calculator and kind of see it. Calculator will not show you that slant asymptote, but you can kind of see how the shape of this should be right. So what I would say is this: go ahead and do these last two. I will try to post the answers to these, but you should definitely try them on your own. Not every problem is going to have a slant asymptote, and you won't have to do long division unless the power is exactly 1 higher on the top than it is on the bottom. So go ahead and try those. Again, I will post the answers to those for you guys, and see how you do. If you guys have any questions, feel free to send me an email. All right.